Okay, which statistic, and this is important, which statistic is your best unbiased estimation of your mu, your population mean? That's your sample mean. That's all we can find. If you ask me to find the population for every gas station that has unleaded gas and you want to know what their average price is, there's no way I can go to every gas station in the United States and figure out what their price is and then take their average. So what I'll do is have a sample, and I'll take a good sample mean and test it. Now, from that sample mean, because we make a reference to the population and inference about it, that's why we use an interval, rather than saying, okay, your gas price for the population mean is going to be $2.10. I'm going to say $2 to $2.20. So somewhere in between there is your population mean. That's why we do this. So just so that you kind of get used to that. And stop me if you have any questions. These guys, this is the one that I did in class with you. And remember we said 80% in the middle? And your inverse norm actually, if you do your inverse norm, remember when we did inverse norm? We said if you put this in parentheses and divide by 2, you can put that right into your inverse norm. Leave your mean and your standard deviation, your mean as 0, your standard deviation as 1, and then just paste it, because you're looking for a z-score, not an x value. So leave these the way they are. But you can put this in, make sure you have this parentheses, otherwise it's going to take half of 80%. And you don't want that. And again, we use the positive. In reality, it doesn't matter, because when you do your E, if you put the negative in there and then you come down and do your integral plus or minus, it takes care of it anyway. But we just make our margin of error always positive. 75, again, just put it in inverse norm. 1 minus 0.75, divide that by 2, let your inverse norm take care of it. And as you found these, add that to your notes, add that to your table. I gave you the popular ones that we use. Every once in a while we use an 80%. Or we use one of these weird ones, even 85. So add that to your table, even 97, so you won't have to recalculate that. Can everybody do this? Yeah.
How do you do it by hand?
Well, by hand I would take this and I'd say, like for instance, 1 minus 0.85 is 0.15 divided in half is 0.075. If I looked in my table 4, this is in here is where I want to find 0.0750. I want to find this and then trace my, it's going to be the negative because it's small, but then we're going to just make it a positive. That's why inverse norm works really, really well for this. Because you have to do the exact opposite in your table. You have to go to the inside part, find the closest to 0.0750, and then find your z-score for it. You can do it. You can do it. These guys, sampling errors, it's just so that you see there sometimes is a difference between what we find for your sample mean and what actually we could find for your population mean. What happens here is sometimes we don't get a good representation from our sample. Maybe we samples are not enough. And at the end of this unit, we also do this little formula. How do we know how many to make in our sample? So it would give us good results. So sometimes you get a sampling error. The difference between your mean and your population. They gave it to you on a number line. I don't know, maybe you could spot them. They only had 2 numbers to work with. Okay, then these guys, 13, 14, right? I gave you 13 and 14? No. 13 and 14, you had to find your margin of error. Again, use the formula. If you want to, use the interval one and then just subtract the mean from the highest one. And that's your margin of error. But get used to that you know how to use the formula. This again, if you recognize this part, this is the part that we use for our samples. This is from your central limit here, and this is what we use for our samples. Good? Can everybody do this part? Thank you. Sometimes I do feel like I talk to myself. I see Mr. King's problem. I feel his pain. Especially on a Friday when it's been nice out for the past 3 days. I get it. I want to get out of here too. Huh? It's been a long week, you're right. It feels like a very long week. Yesterday, for some reason, I kept thinking it was Friday, so today wasn't a very good Friday to wake up again. It's like, you know, like that Groundhog Day. Oh, do it over, do it over. Yeah. Okay, so now you had to match up your confidence interval with the confidence number. Now, remember, let me have your attention for 1 second. I'm very fussy about this word. You listening? The confidence interval does not increase. The confidence interval gets wider. And you're going to catch me sometimes saying increase. However, there is an infinite amount of numbers between any two numbers anyway. So we can't say that it increases. We can say it gets wider. So it's based on how confident you want to be. So the most confident I want to be is 0.98. So from here, I'm going to go to the widest one. So which one is the widest interval? They all use the same mean. It's A. How would I know what my margin of error is if I'm going to compare these? Subtract. Good. So if you subtract these, what did you get for your margin of error? 2.3? If you subtract these, what did you get for your margin of error? 2.0? Am I the only one working here?
Oh, no, I just eyeballed it, honestly.
Okay, eyeball it. And then these guys, 1.6. So, we're looking for the largest margin of error. That's going to make our interval the widest. You can subtract it from either one you want. Either one you want. It's equal distance from either side. Yeah. Okay, so we matched up this one with A. This one was A. So the next widest one is which one? B.
B.
And the next one, 90, would be D.
B.
And then the last one, oh, B. Sorry, B. And then D. Oh, no, C. What happened here? And D. Okay? We're good with that?
We're good.
And we say the interval gets wider.
Wider.
Not bigger.
Not
Thank you. Thank you, Will. Okay, then number 25. Number 25, this is a good one. I like this one. It gives you your two endpoints of your interval and asks you to find the mean and the margin of error. So if this is my number line, where does my mean fall? Right in the middle. David says right in the middle. So how do I find the middle of two numbers? Add them up, divide them by 2. So I add them together, I divide by 2, and I find my mean is 13.4. How do I find my margin of error? Be careful. You subtract these two numbers, right? Or these two numbers, if you like that side better. And you'll find your margin of error. So you're going to take an interval, find its mean, subtract it from either end to find its margin of error. Technically, if you do that, if you use your calculator step, that's what you're going to be doing. And the calculator step works really nice for this. Questions? Raven, you good? Okay. All right. Well,